Let's look at question number 3. It says a third person comes to the same cliff and throws a rock with an initial velocity of 8 meters per second up. Then it wants us to determine the velocity of the rock before it hits the ground. So just before it hits the ground, we also call that the impact velocity. Okay, so what is that impact velocity? Right, the moment before it hits the ground. And it says, remember, this is the same cliff height. So if we go back to our previous problems, we can see that question 1b says how high is the cliff, and the displacement that that rock traveled was negative 78.48 meters. So that negative is telling us the displacement is down. So the height of the cliff is 78.48 meters. So let's start this problem. We're going to want to write our givens. We're also going to want to start drawing more and more pictures for this class. So I'm actually going to start with our picture. Okay, and just drawing a really simple cliff. Okay, we're starting up here. There's our rock at the start. And based on this problem, it tells us we're going to throw the rock up. It's going to reach some maximum up here. And then it's going to fall down to the bottom of the cliff. So from there all the way down to the bottom. And we can add some details here. We know that the cliff is 78.48 meters high. Okay. And let's start writing some of our givens. So given from the problem says an initial velocity of 8 meters per second up. We don't have to write up because we have a positive 8 meters per second, so we know that that's 8 meters per second up. There we go. We can add that into the picture. And we also know the displacement that we're looking at. Okay, and this is a little tricky because we have to remember the difference between displacement and distance. Now, if we look at the distance traveled, the total distance traveled would be this green part up over here, right here. So we'd take that distance, the maximum height, and then we'd add on this full. So it'd be this green arrow plus this blue arrow. That whole length would be the distance. But our displacement is just the length from start to finish. So it finishes at the base of the cliff. And we know that it's 78.48 meters. And it's not just 78.48 meters. We know displacement also has a direction, so it's a negative 78.48 meters. Okay, now we're looking for V final. Okay, we don't know that. There's one more given that we haven't written that's in all of these free fall problems, and it's acceleration due to gravity. It's negative 9.81 meters per second squared. So, knowing our formulas, the one that works with all these givens is V final squared equals V initial squared plus 2AD. So we're trying to find our final. Whoops, I left out my V final squared, V initial squared plus 2AD. Here we go. V initial is 8 meters per second, and we're going to square that, and we're going to add 2 times negative 9.81 meters per second squared. And our displacement, don't forget, is also negative 78.48 meters. We can take out our calculator. So with a little help from my calculator, I was able to plug this stuff in, and realizing that I have a number equal to V final squared, I had to square root both sides, and we find out that the final velocity, or the velocity right before it hits the ground, is 40.8 0.05 meters per second.